Welcome to a tutorial on graphing presented by the Regent University Math Tutoring Lab. In order to graph equations, we need to go over a few key terms essential for graphing, as well as the main features of our graphs. We will also need to learn how to read graphs, as well as create our own. We will also cover some special graphs that we'll encounter. The first thing we need to discuss is where we'll be graphing. The Cartesian plane is a two-dimensional surface that extends infinitely in every direction. The x-axis of our plane is the horizontal axis that runs through the center of the plane. The y-axis is the vertical axis that runs through the center of our Cartesian plane. The x and y axes meet in the middle of our plane at a point we call the origin. Every point on our graph has an exact numerical value. This value is written as an ordered pair, where the x and y value are placed in parentheses, separated by a comma. The origin has a value of 0, 0 on the Cartesian plane because it is 0 units left or right on the x-axis and 0 units up or down on the y-axis. Other points of interest include intercepts, which are points that lie on each axis. X-intercepts lie on the x-axis and are denoted by the given x value, 0, because there's 0 units up or down on the y-axis. Y-intercepts lie on the y-axis and are denoted 0, the given y value because they are 0 units left or right on the x-axis. These will be important points when we begin graphing. The Cartesian plane is broken down into 4 quadrants. The first quadrant is the upper right-hand quarter of the plane, where x and y values are both positive. Moving counterclockwise, the second quadrant is the upper left-hand quarter of the graph, where x values are negative and y values are positive. The third quadrant is the lower left-hand quarter of the graph, where x and y values are both negative. The fourth and final quadrant is the lower right-hand quarter of the plane, where x values are positive and y values are negative. Now that we know what our surface looks like, let's learn about reading graphs. We need to be able to describe each graph's slope, symmetry, and shifts by examining how it's plotted. The slope of a graph is the average rate at which the value of a graph changes between 2 points. Slope can be negative or positive depending on if the graph is rising or falling. A graph is horizontal if it has a slope of 0. This occurs when the y values of our points don't change. A graph is vertical if it has a slope that is undefined. This happens when the x values don't change between our points. Our first graph has a slope of 2 because for every unit we move on the x-axis, we move 2 units on the y-axis. Our second graph has a slope of 0 at y equals 2, and our third graph has an undefined slope at x equals 2. A graph's symmetry is dependent on what happens when it's reflected. A graph is symmetric about the x-axis if the graph on top of the x-axis is the mirror image of the graph below the x-axis. A graph is symmetric about the y-axis if the graph on the right side of the y-axis is the mirror image of the graph on the left side of the y-axis. A graph is symmetric about the origin if the parts of the graph in the first and third quadrant are mirror images, and the graphs of the second and fourth quadrants are also mirror images. A graph can also be shifted from its original location to a new one. The equation of the graph tells us how it's been shifted. Graphs with constants added or subtracted to the variable are shifted. A graph is shifted vertically if a constant is added or subtracted to the variable after all other operations have been completed. Vertical shifts move a graph up or down by the number of units represented by the constant. In the equation y equals x plus 1, the line y equals x is shifted up 1 unit. Horizontal shifts occur when a constant is added or subtracted to our equation before all variable operations have been completed. These shifts move the graph the number of units represented left or right, depending on if the constant is added or subtracted. In the equation y equals x plus 1, quantity squared, 1 was added before we squared x, so our graph is shifted 1 unit to the left. In order to create a graph, we need to do 3 things. First, we need to find important points on the graph. We do this by finding the x and y intercepts of our equation, and then other pairs of points until we can estimate our graph. To find points of the graph y equals x squared, we find its only intercept, which happens to be the origin, by plugging in 0 for x or y. Next, we can find 3 other sets of points by plugging in numbers above or below 0. This leads us to find the points -1, 1, 1, 1, -2, 4, 2, 4, and -3, 9, and 3, 9. Notice that we plugged numbers in for x and got their squares back for y. Once we have our points, we need to plot them by starting at the origin and finding the x and y coordinates for each point. We do this by finding our x coordinate by moving left or right on the x-axis the correct number of units, and then finding our y coordinate from that spot. We do this by moving up or down on the y-axis the correct number of units. We plotted the points we just found for y equals x squared on the graph here. After we find all our points, we need to connect them using what we know about our equation and what we found for points. This will help us approximate the shape of our graph. Here we start with the first point we plotted, the intercept, and move up on either side to the y-axis. Now let's do an example of creating a graph. We start with the equation y equals x squared minus 2. To find the y-intercept, we replace x with 0 and operate. 0 squared minus 2 equals minus 2, so our y-intercept is 0, -2. Now we want to find our x-intercepts. This time, we replace y with 0 and operate. This gives us x squared equals 2 after moving our 2 to the other side of the equation. Taking the square root gives us x equals plus or minus the square root of 2. This gives us x-intercepts of the negative square root of 2, 0, and the square root of 2, 0. Now that we know our intercepts, let's find 2 more points before we estimate our graph. Let's find the points that have the x values of -2 and 2. Plugging in for x equals -2 into our equation gives us y equals -2 squared minus 2. This simplifies to y equals 4 minus 2, or y equals 2. Now we plug in 2 for x and find that y equals 2 squared minus 2. This also produces y equals 2 after we simplify. So our last 2 points are -2, 2 and 2, 2. We could keep finding more points by replacing x with more numbers, but these should be sufficient. Now that we know our points, we need to plot them on the graph. Let's plot our points from smallest to greatest y value for this graph. First, we need to find -2 on our y-axis. We place our point here because our x value is 0. Our second point has a y value of 0, so we just need to move to the left by the square root of 2 units. Since we're only approximating our graph, it's okay if this dot doesn't match exactly. Our next point also has a y value of 0, but we need to move to the right by the square root of 2 units this time. Our fourth point has a y value of 2, so we need to move up 2 units from the origin. It has an x value of -2, so we need to move 2 units left as well. Our final point has the same y value of 2, but this time we need to move right 2 units to place our point. Now that we have our points, we can probably guess what our graph is going to be. Now that we have our points, we just need to connect them. First, we should look at our equation and see if we can figure out how to connect them based on the shape of the graphs that similar equations produced. We should also always start from left to right or from bottom to top. Unless we have a line, points with a common value probably don't connect to each other. Always be sure to include every point that we plotted. Finally, if we need to, we can use a graphing calculator to check the graph after we create it. In our example, we're going to connect from bottom to top. Based on seeing the graph of x squared from earlier, we can be fairly certain that we're going to get a parabola. Notice how we extend our graph past the points we plotted. We do this because if we'd continued plugging numbers into our equation, we'd have gotten more points moving in these directions. 2 graphs that we'll see most commonly are lines and parabolas. Lines have equations of the form y equals mx plus b, where m is the slope of the line and b is the y-intercept. Below we have the line y equals 2x, where 2 is the slope and the intercept is the origin. Parabolas have equations of the form y equals ax squared plus bx plus c, where a, b, and c are constants. Parabolas are symmetric about a line. Below we have the parabola y equals plus or minus the square root of x plus 2. This parabola is symmetric about the x-axis. Some other graphs we see commonly are circles and those of functions. Circles have equations of the form x squared plus y squared equals r squared, where r is the radius of the circle. Circles are symmetric about their center. Below we have the graph of the equation x squared plus y squared equals 1, which we also call the unit circle. It has a radius of 1, and is centered at the origin. It is also symmetric about the origin. Functions come in many forms, but all share the trait of being able to pass a vertical line test. Below we have the graph of y equals x cubed. This graph is also symmetric about the origin. Thank you for taking the time to learn about graphing, and for making the most of your Regent experience.